folks, I'm Dr. Jean-Marc Razzioli. I'm an associate professor of computational chemistry, and I'm also the AI faculty fellow representing the College of Science for the 25-26 academic year. So today I'm going to be talking to you about programming fundamentals for AI-assisted coding in Python, a guide for principled vibe coding. Honestly, I've been kind of avoiding doing a vibe coding video up until now because I always have concerns that students are going to go off in sort of a cognitive offloading direction where you sort of just start using the AI to do some of your thinking for you. And obviously, you want to understand what your code does, right? Even if an AI helps you write it, you are responsible for your code. You need to be able to explain every line of it if somebody asks you. In fact, in this day and age, some people are even starting to wonder if people should still learn how to code. And I would say emphatically, yes, absolutely, you should still learn how to code. And I've listed a few reasons on the screen right now. So first of all, AI tools that write code are getting quite good, but the people who can most effectively wield those tools will always be people who can code, right? People who can actually understand the code that the AI is writing. And I do think the job market is going to get more and more competitive. So try to be one of the best people, right? Try to be one of the people who can actually understand what the AI is doing when it's writing code. And second, the better you understand what you're asking the AI to do for you, the better your results are going to be, right? If you're using the proper language to describe what you need, you're going to get a much better result. Third, debugging AI-generated code can be an absolute nightmare if you don't know what you're looking at. So with vibe coding, typically what people do, they ask the AI to generate a code that accomplishes something, and maybe they ask it to write some sort of test as well to see if the code works right. Then they run the code and apply the test, and if it doesn't return some sort of error, they assume everything went okay. But if it does produce some sort of error or an output they don't expect, then they give that and they paste that error or that weird output to the AI and say, hey, fix it for me, right? But they don't know how to fix it. What this can lead to is compounding errors, right? Maybe the AI made some kind of weird choice and you committed to it because you didn't notice that it was there, right? And you keep trying to make things better. You keep trying workarounds to make that weird choice 10 steps ago keep working for you. So rather than repeatedly asking the AI to keep fixing things, it's better if you're part of the process and maybe you know how to fix something. Maybe there's one line of code that's a little off and you say, oh, I see what it did. I can change that. And then you can just change it yourself. And even just thinking about it logically, if the AI tool you're using made a mistake and you're relying on that same tool that made the mistake to fix the mistake, maybe it'll work, maybe it won't. And finally, pure vibe coding is highly unlikely to produce anything truly innovative. So if you're looking to build the next great app that does some sort of service that hasn't been thought of before, you're probably not going to be able to get that whole thing by vibe coding it, right? You can maybe use an AI to write, who knows, 80-90% of the code, but you have to be asking for precise things. You have to really know what you want. And in order to do that, you have to know how to do some programming on your own. Next, I'd like to offer a note for any instructors watching this. I'm sure there are a fair number of instructors out there who are going to forbid using AI tools in programming courses. And I get it. I understand the concern. At the same time, I think incorporating some use of AI tools is necessary in any sort of curriculum that involves programming, from engineering to science to computer science. From what I've seen in my own work, how my research students work, how some of my colleagues in computer science, attending conferences, etc. From what I've seen, AI-guided coding is really starting to become the industry standard. So if you try to kind of hold to no, I'm handwriting every line, my fear is that there's going to be kind of a disconnect in how people learn coding versus how they practice it. So I think ideally you probably want some circumstances where students need to be able to write code without using AI tools, but you should also maybe give them opportunities to write code using AI tools. Now, one big concern that I have, that I think a lot of people have, that's sort of an open problem in this space of educating students who know how to code and solve problems using code, is that if we look at the current people who are working in industry who are so effective using these AI tools, right? They already knew how to code and then they incorporated AI tools into their workflow. Well, it's not surprising that they're so strong using these tools because they know what they're looking at, right? They went through that time where they had to struggle and figure things out. And I do worry that if things just kind of come too easily with students using AI tools too frequently to help them write code, that maybe nothing's really going to stick. So that's something that we have to be really conscious of. And you'll have to figure out what works best for your courses. But what I found in the programming course I teach is that I have students do projects where they're allowed to use the AI tools. They can ask a friend, they can look online, they can do whatever they need to do to try and figure out how to get their code working, because later they're going to get an oral exam on that same project. And I'm allowed to look at any line and say, what does that line do? What does that line do? What if I make this negative? What data type is this? What control structure is that, right? I can ask questions about their code. So even if an AI helped them write it, they're responsible for being able to explain every single line of it to me. So I think oral exams that are structured kind of like a code review are a really good practice. Additionally, I think good old-fashioned exams could be healthy, where students need to be able to explain the concepts behind programming. Perhaps they need to read a line of code and be able to explain it. While I'm on that topic, I think the ability to read code is going to just keep on growing in importance, right? Before, you had to be able to write code and read code. It's always been important to read code, but I think we're going to see more and more programmers who are probably really good at reading code and maybe not that great at writing it, but they've been using an AI to help them write it. So as long as they can read it and they understand what it's doing, maybe they're okay, right? I think things might go in that sort of direction, but who knows? So as far as this lesson goes, I'm going to jump back and forth a little bit between slides and some live coding. And that live coding I'm going to do in a Google Colab notebook. So Google Colab notebooks are a really handy coding environment. You don't need to install anything on your computer. They actually work quite well. And if you're familiar with Jupyter notebooks, it's very similar to a Jupyter notebook. So if you think of a Microsoft Word doc that is on your computer, right? It's saved on your local computer, and then you compare that to like a Google Doc that's stored in your Google Drive, the comparison is the same thing, right? Like locally, you could have a Jupyter notebook saved on your computer, or you could have a Google Colab notebook saved in your Google Drive. So I love using Google Colab notebooks for tutorials like this because students don't need to install anything at all. And I have another video that covers that, so I won't be covering that today, but I'll be sure to link to that video in the description. So before going any further with this video, I want you to pause it and go open up a Google Colab notebook, right? Because coding is not a spectator sport, right? You have to actually do it. So I invite you to go open up a Google Colab notebook right now and hit pause on the video and come back. All right, so hopefully you have your Google Colab notebook ready to go now. And we're gonna go through a few more slides and then we'll go back and forth between the code. So why Python? Why am I teaching this in Python? Well, Python is free, open source, it's reproducible, shareable. There's a huge community around Python. There's an amazing community around Python. And there's people creating different functionality for Python all the time. So we'll get into what a library is. But basically people can create new functions that you can use and they put them out there for free. It's also one of the most popular languages for doing scientific data analysis. And as a professor of computational chemistry, of course, that fits right in with what I do. Finally, ChatGPT and a lot of the other AI tools out there that can help you with coding are trained on all kinds of different programming languages, but I think Python tends to be the one that they've pulled in the most training data from. So the models are also really good at writing Python. Also, Python is a highly readable language. So as I was saying before, if you're planning on using an AI to help you write code, then you want to be able to read it to understand what it's doing. So it makes sense to choose a highly readable language like Python. So I think I got a little bit ahead of myself earlier and told you what Google Colab is already, but it's a cloud-based Jupyter Notebook environment. You don't need to install anything and you can share everything via Google Drive. They're pretty amazing to use. All right, so now let's get into some essential Python concepts that you should really know if you're going to attempt to do any sort of AI-assisted coding or vibe coding. So let's begin with objects and variables. So Python is an object-oriented language, which means that pretty much everything you work with in Python is an object. Okay, so what's an object? Well, that can be kind of a complex question, but for the time being, I want you to just think of it as something that can store attributes, so things about it, and methods, things it can do. But maybe that sounds a little bit abstract, so let's use an example of an object. Let's talk about a car. So now, in this moment, don't think too hard about what an object is. Think of how you would normally describe an object: a computer keyboard, a glass of water, a car, right? An object. So thinking about cars, look at the car on the screen. Let's think about an attribute of that car. Well, the car's color is orange, so that's an attribute, right? So that's an attribute of this particular car. And if you look at the screen, what we have is what we call pseudocode. So if you write code that sort of shows an idea, but it doesn't actually run, we call that pseudocode. And the first line is import cars, right? That's not saying that the cars are imported. I'm more saying that, like in our session, right? Let's say we just opened up a Google Colab notebook and we want to start doing something involving cars. Well, I have to bring in the software that I need to talk about cars. So import cars just means to bring that cars software into our environment. Okay, so we've brought in that library cars, and there's a specific object within that library that we want to use, and that object is called Mustang. So if I want to create an instance of a Mustang, I would do cars.mustang, right? And inside of that, I've assigned an attribute. I said color equals 243, 74, 58. So those numbers represent red, green, and blue. So any color you can see on a computer screen is some combination of red, green, and blue. And if you max them all out, you get white, right? If you set all of those to 255, you get white. If you set them all to 0, you get black. And every other color is some other combination of numbers. But for this particular example, I want you to focus on the fact that I'm using the library's cars. I'm accessing a specific object Mustang by using the dot, right? So cars.mustang is accessing a particular type of object called a Mustang. And this particular instance of a Mustang is being assigned to a variable Julius. So an important concept I want to cover right now is the assignment operator. So in programming, if you want to assign some value to a variable, in Python is a single equal sign is how you do that. So I have Julius equals cars.mustang with the color on the inside. So what this means is I want to create a specific instance of the object Mustang, and I'm going to name it Julius. So this is just like if someone goes out and gets a Mustang, a bright orange Mustang, and decides to name it Julius, right? Who would do such a thing? Then that's what we're describing here, right? There's lots of Mustangs on the road. They're everywhere. But if you have one particular Mustang that you have created an instance for, that's what we're talking about here. So objects, you can think of them, they're not physical objects in programming, right? They're code objects. But nonetheless, you can think about them that way. They name these things object for very good reason. So that next line of code, we're accessing one of Julius's attributes. So we're saying print. Print is a built-in function in Python. And if we pass Julius.color to the print function, it's going to print out the color for us. And notice how we access Julius's color attribute. It's .color. So that dot is an important thing. And so if you're going to have an AI start writing code for you, you're going to see this sort of thing all the time. You're going to see something dot something else. So it's important that you find out what that means. So this is an example of an object's attribute. It's color orange. Now let's talk about a method that this object has. So methods are actions. For example, Julius.do a burnout, right? That's an action. We just told Julius to do a burnout. So attributes are like properties and methods are actions. Notice that they're both accessed by having the name of the object and then a dot and then the thing you want. Also notice that the attribute color does not have two parentheses following the word color, right? But Julius do a burnout, the do a burnout method, that does have parentheses after it because methods are functions. And just as you write f of x, right, in your calculus course, we say f parenthesis x parenthesis, right? That's f of x. Same thing here, that's a function, so is this, so we have parentheses. And notice that the parentheses are empty, but if you call a function and you don't give it any inputs, you still have to put the parentheses. So once again, Julius's color is an example of one of Julius's attributes, and Julius do a burnout is an example of one of Julius's methods. All right, let's start doing some coding. Let's take a look at your Google Colab notebook and have the video in one tab and have your Google Colab notebook in the other tab, and just pause the video and go back and forth and try writing this code along with me. So we're going to begin our discussion still on the topic of variables and objects. All right, so I have taken the time to type all that code in that was on that slide. And you'll notice that some of it is green, and we see the pound symbol, or perhaps you call it a hashtag, commenting out some of the lines of code. So what do I mean by commenting out? Well, you can have lines of code that don't do anything functionally, right? So like I can type whatever I want here. Now if I hit Shift Enter to execute that cell, right? So that's how you execute a cell in Google Colab, Shift Enter. So if I execute that, we see that this nonsense I just typed doesn't do anything, right? Because this hashtag is here. By the way, a quick trick, if I highlight all of this and I hit Command / it turns the comments back into code. Command / turns them back into comments. Good thing to know. All right, so here I have a variable X and I'm assigning it hello in quotation marks. So what I'm saying is the thing on the right side of the equal sign. Remember, a single equal sign like this is an assignment operator. I'm assigning this word hello to this variable X. And we call this data type a string. And we'll get into that a little more moving forward. But right now, this is a string. So if you have just sort of plain text, you tell Python that you intend it to be plain text by putting quotes around it. So right now, the variable X is holding this string, right? So if I were to just print X, it prints out hello. All right, so now print is a function that is native to Python. This is what Python, we call it a built-in function. So print is just there, right? If you open a Python session in Google Colab, you have the print function. It's built in. Now, if we look at this line right here, y equals x dot upper. So we have x dot upper with parentheses after upper. So pause the video, think about it for a second. What does that mean if I have my object x and then I hit dot upper and it has parentheses? Specifically, is that a method or attribute that I called from x? It's a method, right? So if I run this, nothing new happened in the print statement, right? It just printed out the hello because all I did was print out x. But if I switch this to a y, let me print out y instead. Take a look at that. It turned all the letters into capital letters. So now it's in all caps. So by creating a variable x to which I assigned the value, the string hello, clearly x is an object and upper is a method that is built into a string object. So if you have a piece of text in Python like this, you can always call the dot upper command and it'll make everything all caps. All right, let's delete that again. And now let's look at the type. So if I want to know what data type is x, I can print out the type of x, right? So if I run this, it printed out hello because that's from this print statement. And it also printed out the type of x. So it says class str. str is the string class, so that is a string. So returning to our slides, I have a few common data types. This is definitely not every data type in Python, far from it. But here's some common ones you'll see all the time. So int, if you say x equals 3, that's going to define x as the integer 3. If you say x equals 3.0, it's going to make it something called a float. And a float is a decimal. So if you want numbers that include decimals, that's called a float. One thing that's really nice about Python is that it is what is called a dynamically typed language. So that doesn't mean like dynamically typing, like you're typing on your keyboard really fast, right? It means that your data types can change. So Python basically does its best to figure out by context what you want. So it can just turn a float into an int or an int into a float, depending on the scenario. Whereas other languages, you have to choose what data type a particular variable is, and then that's it. You don't change it. Next, we have a string. Well, you've seen strings already, right? So string is plain text. You know it's a string because it's in quotations. Python also knows that it's a string because it's in quotations. So you have to make sure you do that when you mean for something to just be plain text. A bool is just true or false. It's short for Boolean. So you could say x equals true with a capital T, and then that variable x is holding the value true. And so for the data type Boolean, there's only two possibilities, true and false. And finally, another type of data types that we have in Python are collections. So there's a few of these things. Two of the most common ones are lists and dictionaries. There's also something called a tuple. But basically, if you want to store a collection of data together in one particular object, you want to think about using things like lists, dictionaries, things of that nature. And similar to how Python knows that something's a string based on the quotes, Python knows that something's a list because you use square brackets to hold everything with the elements separated by commas. Whereas a dictionary, you have something called a key value pair, and you put those in curly braces. Don't worry about it if you didn't follow all the language I just used, but it's good that you've heard it, that you're starting to hear these words, and perhaps start looking them up as they come up. All right, up next, we have control structures. So we learned some data structures, ways we can store data. How about control structures that control how our code runs? There are so many more control structures out there other than these, but I thought this would be a good place to start. Number one is an if statement. So if something is true, do this. If something is false, do that, right? Or you can do if and else. So these are different types of statements you can do that evaluate based on some sort of condition. So let's code up an example. Let's think of a simple example. Let's say we want to control some sort of valve that runs a sprinkler for grass, right? And you want to check, you have some sensor out in the grass that measures whether or not the grass is wet. And if the grass is dry, you want to run the sprinkler. So let's say we have some sort of variable here. Let's say we have a Boolean variable. Let's call it grass is dry. So grass is dry equals false. So now if I put an if statement, I could say if grass is dry, I'm going to give it a print statement. I'm just going to say print run sprinklers. Whoops, I spelled grass wrong. Important thing about programming, even little typos. Got to get everything perfect. Okay, so I executed this cell and nothing happened. Well, the statement says if the grass is dry, right? If grass is dry, print run sprinklers. But is grass dry? False. Grass is dry is equal to false. If I change this to true and I run it, now it says run sprinklers. But let's say we want to do something either way, right? If the grass is dry, then run the sprinklers. If the grass is wet, tell me that it's raining so I know to grab an umbrella. So that's if else, right? If grass is dry, run sprinklers. Else, tell me to get my umbrella, right? So I could type else print get an umbrella, right? So now if I run it, it still says run sprinklers because grass is dry equals true. But if I change this to false, false, now it says get an umbrella. And again, you can do a lot more with these. I just want you to have a taste of what you're looking at when you read code that's been written by an AI tool. We also mentioned for loops. So for loops are something you want to use if you want to do something kind of repetitive and you know how many times you want to do it. So I'll give you an example. Let's say I have a list of numbers. We'll just call it numbers. A list, square brackets, right? Let's go 4, 6, 8, 10, right? These are my numbers. Shift enter. Now that variable numbers is holding this list 4, 6, 8, 10. And let's say I want to do a for loop where I print out twice that number. So if I go for number in numbers, this is something called a for loop. And again, this syntax, I want you to see it so you're familiar with it so that if you read it later on, you know what it's doing. Like, oh, for loop, it's doing something repetitive. Okay, so for number in numbers. So I could say number, actually, let's go print number times 2. If I run that, it goes 8, 12, 16, 20. So it worked. So this is an example of a for loop. Notice how well it works with things like lists, where you want to go down a list and operate in some way on each element of the list. This is a great use case for loops. We also talked about while loops. So what's a while loop? Well, if you want to do something again and again until some condition changes, you want a while loop. So now coding up an example of a while loop, let's start with some condition. Let's say that x equals 5. And let's say while x is less than 15, while x is less than 15, let's tell it to, let's just print x. Print x. And if I ran it just like it is now, right, this would throw an error because there's nothing changing the value of x. You're saying while x is less than 15, print x. Well, nothing's ever going to change x in this code cell, right? So it'll just run forever. That's something called an infinite loop. You have to be careful to avoid these things, and so should your AI coding buddy, right? And I think they're probably pretty good at avoiding these. So let's put a step in here where we make x increase by 1 each time it runs through this loop. So if I say x equals x plus 1, and now I run it, there we go. It stops at 14. So we initialize x equals 5, then the while loop starts, and we say, okay, the while condition, while x is less than 15, then we step inside the loop and we say, okay, first you got to print x. Great. Next line, we're going to assign a larger value to x. And now look at this line carefully. If you are in a math class and you write x equals x plus 1, let's say you're in an algebra class, x equals x plus 1, is this problematic? Think about that for a moment. Yeah, right? You have x would cancel on both sides and you'd be left with 0 equals 1, which is wrong. That is not true. 0 is not equal to 1, right? So mathematically, this actually doesn't make a lot of sense. But in terms of programming, using that single equals sign as the assignment operator, it actually does make sense because first, whatever x is right now, add 1 to it and then assign that to x. So that's what's going on here. So first x equals 5. Since 5 is less than 15, we step inside the loop and we print out x. Then we go to the next line and we say, okay, add 1 to x and assign that value to x. So 5 becomes 6 and so on until we hit 14. So notice it didn't make it to 15 because when it hits 15, that would evaluate to false. And then you wouldn't make it to the print statement. It'll kick you out. And since the assignment operator came up again, let me show you one other thing involving the equal sign. If I say x double equal sign 5, that's going to evaluate to false. Why is that? Well, it was 5. Then I went through this loop, and we note that the last time we saw x printed out, it was 14. So let's try 14. If we say 14, still false. What's going on with that? Well, we'll notice that at the bottom of the loop, we have x equals x plus 1, right? So it got up to the value of 15. It just never printed it because the while loop said, whoa, hang on, you're no longer less than 15. We're done with this loop. So it just didn't get printed. So let's try 15 now. Now it's true. So single equals sign assigns a value, right? This assigns a value. This asks the question, is it that value? All right, next let's talk about Python functions. So we've talked about them a little bit, right? We talked about methods that are built into objects. That's a function that comes with an object. It's built into an object that you can use it, right? Julius the Mustang dot burnout, it'll do a burnout, right? That's applying a built-in function called a method. But let's address functions a little more generally now. So there are functions that are just sort of there in Python. They're built in. They're just kind of floating there, right? They don't have to be attached to a particular object. And examples of this are the length function and the type function. So going back to our Google Colab notebook, so here's an example of the length function. So if I go len, and let me pass something to the length function, let's pass a string to it. If I pass a string to it, I'll just put my first name in there. The length of that is 8 because there are 8 characters in the word Jean-Marc. But the length function can also accept other inputs. So another input to length, let's give it a list. So here we have a list of numbers. Let's give it the list of numbers. So if I say length of, we named our list numbers, so I just have to type the variable name numbers, shift enter, and we've got 4 because there's 4 elements in that list. Is that true? Yeah, absolutely. 4, 6, 8, 10. There are 4 elements in that list. Another built-in function is type. So if I type the word type like this, and then I put, let's give numbers again. If I pass numbers to that, it tells me that's a list. So if you want to know your data type, what kind of object is something, pass it to the type function. And again, these are two examples of built-in functions. I didn't have to have some object dot and then the function. These are just in there. They're built into Python. And we've already talked about functions that are built into objects. These are called methods. But let's do one more example in Google Colab. So I mentioned that numbers is a list. Well, any list has all kinds of built-in functions called methods, right? Just like if you get a Mustang, whether or not it's Julius or any other Mustang, you can do a burnout in it. So let's test out one of the methods built into numbers. So I'm gonna type NUM, I'm gonna hit the tab key. See how if I hit the tab key, it finishes it for me, right? This is a great feature. You should use it all the time. It'll save you a ton of typos, it'll save you a ton of time, and it'll save you keystrokes on your fingers, right? If you're in the sort of role where you're writing a lot of code, anything that saves keystrokes, it will pay off. Maybe if you're young, you don't believe me, but eventually you will believe me. Okay, so let's go NUM tab, and then I'm gonna hit the dot, right? Because I wanna access some methods. Well, look what happens. If I hit dot, Google Colab is suggesting all sorts of things, right? These are different things that you can do with a list. So let's try append. So I'm going to use append. Append is a method, so I need parentheses because, methods are functions and functions have parentheses. And I'm going to pass something to append. So I'm going to pass a number. Let's see. So, because remember, numbers is a bunch of numbers. So let's pass a new number. Let's pass the number 99. So if I append a 99 to that, and now I print out numbers, look at that, 99 is now added to the list. It's now included in the list. So by calling the built-in method for that object, that function modified that object, right? I didn't have to set that equal to a new variable or anything. It was that object that got modified because I called its built-in method called append. And if you want to remember how append works, just think of if you add something to the end of a book, what do you call it? An appendix. Right? That's something you put at the end. So if you put something to the end of a list, it's called appending. So that's one more example of calling a method built into an object. In this case, we're calling the append method that is built into all list objects. Up next, we've got user-defined functions. So you're not limited to the functions that other people have made for you or that are built into Python. You can make your own functions. So let's go back to the Google Colab notebook and let's try defining a new function of our own. So let's define a function that takes your age in years and it converts it to months. So if we're going to define a new function, we have to type def. That's what tells Python, hey, I'm creating a function. So let's say def your age in months. So we're going to tell this function our age in years, and it's going to tell us our age in months. So we'll say age in years is our input. So when you define a function, you have to name what your inputs are going to be called. And again, I'm moving quickly through a lot of things. This is about gaining familiarity. Type along, try it yourself, but this is about familiarity. Don't worry about every possible exception or how things can be, right? You're going to learn more by working with the AI to write code, right? This is about being familiar with things. So I want you to be aware of it when AI-generated code is defining new functions that it uses later. So what we're going to do is we're going to print out you are age in years times 12 months old. All right, so, straightforward math here. There's 12 months in a year, so you just multiply by 12. So that's a print statement. And we're also gonna put a return statement. And so what the return statement is gonna do is it's gonna give us that value. So I'm gonna copy this, age in years times 12. I'm gonna put it here. So there it is. So if I hit Shift Enter, it looks like nothing happened, right? Because all I did was define the function. I haven't used it yet. So this is defining a function. If you use a function, it's called calling the function. So if you call the function, you're like, hey, function, do the thing you do, right? That's calling a function. So if I call it, Now I don't use def this time. I just type the name. And notice I use the tab key, save myself a ton of keystrokes. Your tab, there we go. And let's say somebody is 35 years old. Whoops, 35 years old, and I hit Shift Enter. You are 420 months old. All right, so it printed this out, and then we see this output down here, right? So there's a 420 again, so this is return. So the reason I'm showing you this is something that I've seen students get mixed up again and again with are print statements versus return statements. A print statement is all talk, right? It's just telling you something. That okay, you're 420 months old, fine. But that didn't get like saved anywhere or anything like that. But if I run this function and then let's say I call it my age. I'll just say my age is that, right? Now I'm creating a variable called my age, and whatever this function outputs, I'm using the assignment operator to assign it to my age. So now if I run this, notice I still get the print statement, you are 420 months old, right? But we no longer see that 420 at the bottom. But now if I print out my age, there's the 420. Right? So my age is storing that number. I've stored that number 420. So the return statement determines what's going to get assigned to variables. If you run this function on the other side of an assignment operator, right? So right here we say a variable my age and we call the function. The output from that function is given by return. That's the thing that gets assigned. Printing it, it's just talking to you. Printing is all talk. All right, so that's a simple example of a user-defined function, and you'll see this all the time. And the last type of function we're going to talk about are functions imported from libraries. So as I mentioned, Python has lots of great built-in functions. You can define your own. But let's say you want to plot some data and you think there must be people who have written libraries to plot data. Yeah, you don't have to write your own functions. There's lots of other functions that other people have written. And this is one of the many reasons why the Python community is so strong, is because there's so many developers all over the world who are constantly developing new useful functions that they give to other people to use for free. All you have to do is install the library and then import it into a session. So what's the difference between installing and importing? Well, if you've installed Microsoft Word on your computer, but it's not open right now, right? That's an installation. It's installed. It's there if you need it. And then when you turn it on, that's kind of like importing Microsoft Word into your current session of using the computer. It's kind of like that with Python libraries. If you've installed it on your computer, you can use it anytime you want, but it won't get loaded into your current session unless you import it. And the reason for this is that there are far more libraries out there that could do so many different things. If you loaded all the functionality that you have installed into Python in every session, you'd be wasting so much computing power just storing all these methodologies and objects and everything else that you're not even going to use. So let's look at an example of importing a library and then using a function from it. Now, one of the most famous Python libraries is NumPy. So if I say import NumPy as NP, there, it suggests it for me. I just hit the tab key and there we go. If I run that, what I've done, I've imported the library NumPy. That's short for numerical Python, right? It's for doing numerical operations in Python. What I've done is this as NP, it's giving NumPy a nickname. Basically, all I have to do is type NP if I want NumPy. I don't have to type all of NumPy out. And you'll find that that's super standardized. When people import NumPy, they always say import NumPy as NP. So your code should be doing the same thing. And if you're getting AI generated code, I'd be shocked if it did anything other than this. So now I have an object NP that has all kinds of functions built into it. So if I hit NP dot, look at all these different things I can do. I'm just scrolling through some of the many, many different functions that are inside of NumPy. Look at all this stuff. There's so much stuff. So let's just do SQR, that's square root. Here's a square root. So if I want to take a square root using NumPy, right? I take the object where that library has been imported to, right? So import NumPy as NP. So if I want to call methods that are from NumPy, I have to go NP dot square root. Let's take the square root of, well, we did 99 before. Let's do it again. 99, and there is the square root of 99. So it's this floating point number here. And notice the print statement here. It's saying NP float 64 and then this number. So this is actually a fairly recent change with Python, where if you print it in a Google Colab notebook like this, if it is a NumPy floating point. So this means NumPy floating point with 64 bits. So you can assign different numbers of bits to different types of numbers. This happens to be a 64-bit floating point number, and this is the value that it has. So this is actually the value. All right, so that's an example of importing a library and then using a function that's built into that particular library. And there are, I have no idea how many Python libraries are out there, but there are a lot. But these are some of the most famous ones. There's NumPy, which we just saw. There's Pandas. So that's for Python and data science. So data scientists use Pandas all the time. All sorts of scientists of all kinds use Pandas all the time. It's a great library. I love it. There's matplotlib, which is for plotting. And Seaborn is kind of fancy plotting. So you can make all sorts of amazing looking plots using matplotlib and Seaborn. In fact, you can make plots that look just as nice as plots that you would make using software you have to pay for. And Python's free. So just to show you one more example with libraries, let's do an example using Pandas. So first, let's import Pandas as PD, right? This is the way people always import Pandas. So when you import Pandas, always do import Pandas as PD. And I'm sure, again, an AI, a code generating AI will absolutely import it this way. So now that Pandas is here, we can use it. But let's get some data. So I have a data set here that's just like a little practice data set for things, demonstrations and things like that. I have this data right here. This is just pointcloud.csv. If I open this using a text editor, we see that it looks like this, right? Bunch of data, XYZ cluster, right? So we've got all sorts of data points here. And this is what's called a CSV file, comma separated value. So if I open this file using Excel, if I right click, open with Excel, Excel knows how to handle a CSV file. And it's gonna look like this. So there we have it, XYZ, and then a cluster ID number. So 0, 1, 2, tells us which cluster it belongs to. So I'm gonna go ahead and close this. But what it really looks like is that text file I showed you first. It's just that Excel knows that if you're gonna open that file with Excel, it knows what to do with CSV files. Likewise, if you're working with a data set in Excel and you wanna start using Python for your workflow, export your Excel files as CSV files and use them that way. There are Python libraries that can accept Excel files as input. I don't think they're worth the trouble. I think you know, this is a biased opinion. Of course, some people might think they're great to do it that way. I think it's better to just export it as a CSV file and work with it that way. So if we want to work with this point cloud CSV file and we want to work with it in our Google Colab notebook, you actually have to upload this file. So what I'm going to do, I'm going to click on this folder icon here, and I'm going to drag our point cloud data right there. It's warning us that, fine, we're uploading this file, but they're not saving it for us. Like, so this session, when I close this session of Google Colab, it's not going to save this file. It's going to delete it, but that's fine because it's saved right here on my computer. I don't need them to save it, so I'm not worried about this. Okay, so I loaded that in, and now this point cloud is right here. So what I can do, I'm going to call a pandas function for reading CSV files, and let's call it. I'll just call it point cloud. Point cloud equals pd.read. There it is. It suggested it. CSV, read CSV. And I'm going to give it the file name, but I have to give it the file name as a string. So I need those quotes. And I bet maybe it'll even know. If I do pu point, if I hit tab, no, it doesn't. Point cloud.csv. So now if I run this cell, there we go, it ran with no errors. Let me zoom out a little so you can see better. By the way, if you want to zoom in or out, the command key minus zooms out, plus zooms back in. So, okay, we've got our point cloud here, and let's see what this thing looks like. Point cloud. I'm just gonna output it from this cell, right? So if I hit Shift Enter, there we go, look at that. Here's what it looks like, X, Y, Z, and the cluster ID. So you see how essentially we've read the data into something kind of like an Excel sheet, but we don't have to look at all those cells all the time, right? You might say, if you have never worked with truly large data sets, you might be like, well, what's the big deal with that? Don't I want to see the data? Well, you know, I have a data set in my group that's almost 1 million rows long, and I think it's got like about 43-ish columns, something like that. So like, do you really want to scroll through, you know, 1 million rows to try and find something? No, you don't want to load all of that at once. So this is actually a great way to work with data is in Pandas, is by reading CSV files in using Pandas. And what that does, so this is an object, right? Of course, we've created an object. We've accessed our object for Pandas. We've taken a method from that called read CSV. We gave it its input to tell what file to read in. And then we use assignment operator to assign what's produced by this function to this, right? So something got returned by this function. So let's find out what data type it is, right? Let's find out what data type our variable point cloud is. So hopefully you're remembering on your own, but if you forgot to find out the type, it's type. So if I go, what was it called? Point cloud. Point cloud. Shift Enter. It's a Pandas data frame, right? Pandas data frame. So this is the type. Pandas data frames are amazing. You can do so much stuff with them. For example, there's a built-in plotting function. And let's just run it just super plain vanilla. I won't give it any inputs. And let's just see what it does. If I go point cloud dot plot, and let's just see what it does. Oh, look at that. So it's plotting them as a function of time for X, Y, and Z, and then the cluster value. Oh, that's funny because there's only 3 cluster values. So, but look at that. Look how easy it was to make a plot. Granted, this isn't how you probably want to plot this data, right? But, you know, while we're talking about AI-assisted coding, let's go to ChatGPT for a second and say, I have a CSV file with, I think it's 3 clusters of points. Please, let's see here. The data is loaded into a Pandas data frame. Can you please write Python code to plot these 3 clusters of points in 3 different colors? Let's see. And I'll attach the file so you can read it. All right, and now I'm going to take this file that I have that I uploaded to Google Colab earlier. Let's give it here. So if I give that there, point cloud CSV, and I'm going to run this. Enter. See how it does. Okay, ChatGPT did a good job reading what it looks like. It's going to write a function for us. It's thinking about it. Let's see what it comes up with. So notice, ChatGPT these days is getting really good at just making things for us without, you know, including us in the process, really. We don't know how this was made, right? It looks good. This is about what we want to see. But, you know, I want us to get a code. I want us to be part of the process. I think it's dangerous to have ChatGPT do your analysis for you, right? This is a simple thing, of course, but, you know, this is just an example to learn from. So let's actually get the code. So if I click here, there we go, view analysis. Here's the actual code. I'm going to click copy code, right? So instead of clicking here and just downloading that chart, I could do that, but let's actually get the code. I'm going to paste this code right here. And let's take a look at what it did. All right, so it imported Pandas and some other libraries as a plotting library. This is a clustering library. So this one is okay, so the fact that it is importing this, I know is from my experience that it doesn't realize we already know what the clusters are. So if you look at our data, it had a column for cluster, but it still thinks we need to figure out which cluster is which. But that's already there. So it actually didn't need that. You know what? I think let's ask it. So it went down a path. So by reading this carefully and not just running it, it went down a path thinking it needed to do things it didn't need to do. So let's give it some feedback. Actually, the last column called, was it capitalized? Yes, called cluster has the cluster identification numbers in it. So you do not need to do k-means clustering. So this is important, right? Because it looks like it just plotted our data based on like what our data told it, but it actually ran clustering. So this is a perfect example of why you need to see the code and see what it did. Because if I already had the data, I already had the clusters labeled how I wanted them labeled. Reclustering them could have messed that up. Okay, so let's see what it does this time. So I caught a mistake it made, but it's a mistake that you wouldn't notice unless you could read the code. All right, here we go. So now it redid it. The plot looks good, but let's go down to the actual analysis here, the code here. So it reads in the data frame. Okay, let's copy this. So I'm going to copy this code. I'm going to go here. I'm going to delete all of this because that's not what we wanted. Put that in there. Okay, so here it's reading in the CSV file. Well, we've already done that, and it's calling it df. Well, since we've already done that, why don't we just use the assignment operator? And let's just say point cloud, because it was called point cloud. So we're going to take point cloud, put it here, and we're going to assign it to df. So now df is just holding point cloud. And you know what? Let's just go for it. Let's see how it does with that. There it is. So it worked, right? So now we have a plot, and we can look at this thing. We could say like, okay, what if I don't like the colors or things like that? I could change things. There's all sorts of things you could do to change this. But now you have the code. And so now not only is the process transparent, you know how the analysis is being done, you also have a reusable code that's going to work the same way every time. So if you had done this for some sort of process that you do all the time in your research, right? Maybe there's some calculation you frequently do. You can use an AI to help you write code to do the analysis. And then once it's working perfectly, don't touch it, right? Just use that Python code and give it different inputs. So for example, if you had to make cluster plots like this frequently, that's something you could do. You could do this all the time and just, give it different data, and that code base will just work. All right, so that concludes our presentation here on programming fundamentals for AI-assisted coding in Python. I'm Dr. G. Thank you so much for joining us. Please like, subscribe, share, etc., and I'll see you in the next one.